Hi, I'm Diane, and today we're going to use systems of equations to understand how I can beat Usain Bolt in a foot race. We're going to start with a really high-tech simulation of this race using a couple of sorry pieces and some key information. I made a start line and a finish line. I'm going to be the red sorry piece because I have red hair, and Usain Bolt is going to be the blue piece. Usain Bolt has run the 200-meter race in 19.2 seconds. His average speed has been 10.4 meters per second, or about 23 miles per hour. That's super fast. I can't run 23 miles an hour. With some serious training, I think I might be able to average about 6 meters per second. So if Usain Bolt and I both start at the same place and we start running at the average speeds that I described, in 1 second you can imagine that I would go about 6 meters and Usain Bolt would go about 10 meters. And 1 second into the race, I'm already losing. If we go 1 more second into the race, Usain Bolt would go another 10.4 meters, which would put him at 20.8. I'd go another 6, which would put me at 12. I have no hope of catching up at this point. The only way for me to have a chance of competing is for me to have a significant head start. I'm going to give myself a 75-meter advantage in the 200-meter race. And so now my new question is, if I start 75 meters ahead of where Bolt starts and we both start running at the same time, will I win? At time 0, my distance is already 75. Bolt's distance is 0. We could start building a table of values knowing our speeds. 1 second after the race begins, I'm going to go 6 meters forward. 75 plus 6 will be 81. 1 second after the race starts, Bolt will travel 10.4. I'm still ahead. Woohoo! 2 seconds in, I'm going to go another 6 meters. That's going to be 81 plus 6, 87 meters. But Bolt's gonna travel another 10.4, so he's now at 20.8. He's gaining on me. We could continue building this table of values to see what happens as we get closer and closer and closer to the 200-meter finish line. At 17 seconds, I've gone 177 meters, and he's gone 176.8. By second 18, he's passed me up. So sadly, 75 meters was not enough of an advantage for me to win. And so what I want to do now is use a graph to figure out how I might decide on a good advantage. The first thing I did was I made a graph of Usain Bolt's distance over time. If I make my x-axis seconds and my y-axis meters, he's traveling at 10.4 meters per second. And so I can graph his time as 10.4x, or 10.4 times the number of seconds that he's traveled. The red line is my speed of 6 meters per second, 6 times x. This graph shows both of us starting at the same start line, so the only time we're ever in the same place is at time 0, distance 0. From this graph, what we can see is that as the race goes on, we are farther and farther apart. Bolt is leaving me in the dust. Here's a graph showing the race that we ran with my 75-meter advantage. What's interesting about this graph is Bolt is still starting at distance of 0 at time 0. But for me, at time 0, I'm all the way up at 75 meters. The slope of my graph is still the same. I'm still traveling at a rate of 6 meters per second. For a long time, I'm ahead of him, but he's closing the distance. And then here where we see the two lines cross, this is where we are exactly tied. And then over here, we see he passed me up. I changed my graph by adding 75 to it, which shifted the graph up the axis. That showed the advantage that I had. The question I want to leave you with is, how far up the axis do I need to shift that graph to give myself enough advantage that Usain Bolt does not pass me before the finish line? In that case, the point of intersection of the two lines is going to have to happen after 200 meters.